Exponential growth and decay. We've started talking about this the last couple days. We never quite got directly to talking specifically about growth and decay because we were talking about equations or we were talking about solving word problems or something like that. But today we're really going to focus on knowing what growth and decay is, knowing the difference between the two, and being able to pick out the rate of growth or the rate of decay. All right? So how do you know if something's a growth or decay? Let's talk about this first. You remember this equation from a couple days ago, right? A times b to the x? Yes? Okay. On that same day, we also talked about the fact that sometimes b has to look like this. Remember that? Where we talked about earning interest for 20 years or our car depreciating for 20 years. You remember that? Okay. So I need you to know by looking at an equation like this, or like this for that matter, just by looking at the equation, whether it's growth or decay. I need you to be able to tell that. So there's something special about B that will tell us if it's growth or decay. Excuse me?
It's negative or positive?
That's a good guess, but not quite. Okay? So how are we going to tell if something is growth? I'll give you a hint. If b is greater than 1. That was a good hint, huh? Yeah, that's the answer. Okay? If b is greater than 1, then it's going to be exponential growth. Uh-huh. Yeah. How are we going to tell if it's decay? If b is less than 1? Close? Yes. That's much better. Between 0 and 1. Okay? Yeah, it's okay. So we have to be able to tell by looking at one of these two equations. We know they mean the same thing, just depending on the situation which one we have to use. But we need to be able to tell by looking if it's growth or decay. All right? After we tell if it's growth or decay, we have to be able to figure out the growth or decay rate. What do you think? Where do you think we're going to find the rate? Oh, yeah. The R. So it might start in this form, but we've got to get it in this form. God bless you. To make sure that we can see the rate. Okay? So let's start with the sample problem. How about that? Now, for these particular problems today, we don't care about A. That's not our focus. So we are leaving it just A. We're not going to put a number in there because I'm afraid that will confuse us. We're just going to leave it as an A for today. Okay? So we have y equals A times 0.5 raised to the t over 28 power. Now, is this the same thing? Is t over 28 the same thing as t times 1 over 28? Yes? Okay. Which means what I want to do here is I want to get rid of this 28. Why in the world would I want to get rid of the 28? Does that have anything with it right there? I don't want anything with that, do I? I just want the x up there. If just the x is up there, that'll help me a lot with this. So I've really got to get rid of that 28. Well, because of the properties of exponents that we talked about yesterday, we know that we can say that this is true. Why can I say that? Well, I know if I'm at here, I can multiply those two things because that's what our properties of exponents tell us. So does it make sense that I can separate them out this way as well? Why would I want to separate them out that way? Yeah, first of all, it gives me the t all by itself as the exponent. Second of all, is this a number I can figure out? How would I figure that out? Calculator, absolutely. Okay, so in your calculator, I want you to figure out what 5 to the 1 over 28th power is. Today we're gonna go to the thousandths place. What does that mean? Tenths, hundredths, thousandths, right? So 3 decimal places is what we're going to on our examples and on your homework tonight. Okay? So somebody tell me, what is 0.5 to the 1 over 28th power? 0.975 or 6? Are we in agreement? To the t power. So we can already tell one thing. What can I tell by looking at that number right there? Are we talking about growth or are we talking about decay? How do you know we are talking about decay? It's less than 1 and greater than 0. Okay? Now I have to figure out my decay rate. So it's got to be in this form, 1 plus r or 1 minus r. Well, which one do you think we're going to use, 1 plus r or 1 minus r? If it's less than 1, yeah, I got to use 1 minus r, right? So I have to use my brain. I know that's trouble for some of you. And say 1 minus something to the t power. But that also equals 0.976. 1 minus what equals 0.976? How would you figure that out? Couldn't you subtract 1 minus 0.976 and see what's left over? Do it. Right? 0.024. So that tells me something else now. It tells me that my R is what? 0.024. Except anytime we're asked about a rate, how are we asked about that rate? Think back to the problems we did about borrowing money for a college loan, or think back to the problem we did about buying a car and it depreciating in value. Oh my gosh, it was a percent, wasn't it? It doesn't say 0.024. What does it say instead? 2.4%. So we know that this is decay because this is less than 1, and that we know that decays at a rate of 2.4%. Now, someone asked me earlier a very good question. They said, do we have to put negative 2.4% because we're decaying? What do you think about that? So think about what this means.
That's basically the negative.
That's the negative, right? It's telling us it's decreasing. It's decaying. This just tells us at what rate it's decaying. So we don't have to have a positive or a negative sign on here. This is the rate at which it's decaying, or this is the rate at which it's growing. So we just have to have it as a 2.4% in this case. Okay? Any questions? Let's do another one. Y equals A times 4 to the t over 6 power. What do you want to do first? So separate the exponent. So that's going to be y equals A times 4 to the what power? 1/6. Then that is raised to the t power. Absolutely. Now what? Do you know 4 to the 1/6 4 to the 1/6 power? Yeah, neither do I, but I have a calculator that will help me out, right? Remember, I'm supposed to, according to my TEKS, I'm supposed to teach you how to use a calculator. This is one of those cases where we need to use the calculator. What is 4 to the 1/6 power? 1.259? What's after the 9? Okay, so 1.260 if we're going to the thousandths, right? So what can you tell me? It's growth because it's greater than 1. The B value is greater than 1. What do I have left to find? The rate. How am I going to figure that out? Yeah, that was really hard, wasn't it? No, I know it wasn't. I was just being silly. So now what do we know? 26%. Done. This is in the right form. A times 1 plus r to the x power or to the t power. That doesn't make a difference. Okay? So I can tell that it's growth because it's greater than 1, and I can tell that the r is 0.26 because it's in the correct form. Any questions?